Bismillahirrahmanirrahim. In today's video, we will be solving example 4.17 from Mr. Bolster's book of electronic devices and circuits. And here primarily we'll be discussing common base configuration. So what is common base configuration circuit? Generally, it is drawn like this. Sometimes, as you're more used to, was that the collector goes at the top, emitter at the bottom, and base on the left-hand side. But this looks easier because here the base is directly now connected to ground, and that is why it is called common base configuration. Now, this design is popular because it has low input impedance and high output impedance. So when you go further, when you go into the design of the amplifier, then this point you have to keep in mind. And also this has a good gain. Now this is the question. We have to find four parameters, IE, IB, VCE and VCB. As you have been doing earlier also, that first thing we do is remove the capacitor for DC analysis. So that is what we'll do first, remove the capacitor. And then have written the currents IE, IB and IC and marked their direction. And accordingly, we have marked the voltage across the resistor. We know that wherever the current touches the resistor first, that point is positive, the other is negative. Similarly, in this case, you can see the current is going from here. So touching here first, it will be positive and the other end will be negative. With this in mind, now let's solve. IE, you can see IE is in the left loop. So we can take KVL from the left loop and solve. So KVL, we're starting from the left hand side. I prefer that. So plus VEE, then minus IERE, and minus VBE is equal to 0. And rearranging, because we want to find IE, so IERE left side, and from here IE will be this formula, and now we can plug in the values. So VEE 4 volt, VBE, this voltage, we know VBE is always 0.7 volt. RE is 1.2 kilo. So IE will be 2.75 milliampere. Now, next is IB. I hope you recall the relation between IB and IE is this one, that beta plus 1 IB is equal to IE. So simply we plug in the value of beta and IE we already know. To find IB. Beta is given for the transistor to be 60. So IB will be this formula, plugging in the values, IE beta 61. The answer will be 45.08 microampere. So two parameters we have calculated, IE and IB. Now let's calculate VCE. Now VCE is this voltage, so we take the outer loop and write KVL. So KVL from here, plus VEE, then IERE, then minus VCE, and then minus ICRC, and plus VCC. Rearranging for VCE, and we can replace IC by IE because approximately equal. We have already found IE, so we can just do that easily. So this is replaced by IE, and now we can take IE common from here. And now we can plug in the values of all the parameters, VEE 4, VCC 10, and the current and resistance. So VCE will be 4.1 volt. And finally, VCB, you can see it is on the right loop. So KVL right loop going from here minus VCB minus ICRC plus VCC. So this is the equation. From here we'll separate VCB, and now we can plug in the values. IC we have not calculated, but we can calculate here. We know this formula IC is equal to beta IB. We could have also used IE because IE is approximately equal to IC, but this is slightly more accurate. So replacing IC by beta IB and putting in the values. So VCB will be 3.51 volt. I hope you have been able to follow this. Please let me know through your comments. Thank you.